All right, in this video we're going to talk about exponential functions, and to do that we're going to start by comparing an exponential function to something that we've seen before that is not an exponential function. So let me erase this to get started. Okay, so I'm going to start by drawing a t-chart here with some x and y values. So my x values are going to be on the left, and my y values are going to be on the right, and my first x value is going to be 1, and I'm just going to go up to 4. So 2, 3, 4. And this is a function, and for each line here, when x is equal to 1, we're going to say that y is equal to 3. And when x is equal to 2, y is equal to 6. And when x is equal to 3, y is equal to 9. And when x is equal to 4, y is equal to 12. Now let's start by looking through and seeing what the common difference is between each of these rows here. So between 3 and 6, we have a difference of 3. And so if we were going up in value, then we could say that we're adding 3 at each step, or adding 3 here. And then let's look here. Okay, we're also adding 3 to get from 6 to 9. And then we're adding 3 again to get from 9 to 12. And so if we were going to write a function that described the relationship between x and y, we could write that function like this. We could say that y is going to be equal to whatever x is times 3. This is the function that describes the relationship between x and y. And you've seen this kind of function before. This is called a linear function. It's called a linear function because when you graph this, it forms a line. It's a straight line. Now, I want to talk about something that's not a linear function, this time in a different color. And I'm going to have, again, my x values on the left and my y values on the right. And instead of starting at 1, I'm going to start with 0 here. I'm going to go 0, 1, 2, 3. And for this particular function, when x is equal to 0, then I'm going to say that y is equal to 2. And when x is equal to 1, y is going to be equal to 6. And when x is equal to 2, y is going to be equal to 18. And then finally, when x is equal to 3, y is going to be equal to 54. Now, if this were a linear function, then I would have a consistent difference between each step or each row in this t-chart, but I don't. Here I have a difference of 4, and then here there's a difference of 12, and so on. So it's not a consistent difference. But what I can see here is that there is a consistent ratio between these rows. So to go from 2 to 6, I would multiply by 3. And to go from 6 to 18, I would also multiply by 3. And to go from 18 to 54, again, I would multiply by 3. And so there's not a common difference between each row, but there is what we call a common ratio, because each row, the y value for each row is 3 times as big as the y value for the row just above. Now, if I wanted to write out an equation for this t-chart, I can do it in steps. And so the first step that I'm going to do is I'm going to go through each row, and I'm going to write out what the actual like building blocks are of the equation. So for example, for this first row here, I have y is equal to just 2. Y is just equal to 2 here. I just rewrote 2. And then for the next step here, y is equal to, we started with 2 and then we multiplied by 3 and got 6. So y is equal to 2 times 3. And then for our third row, we have y is equal to 2 times 3 times 3 to get us to 18. 2 times 3 times 3. And then finally for our fourth row, we have y is equal to 2 times 3 times 3 times 3. 2 times 3 times 3 times 3. Okay. Now this isn't a function that we can, or an equation that we can substitute values into to get output. So let's figure out how we can do that next. So you may remember from our talks about about exponents, that when we have repeated multiplication, we can replace it with exponents. And so on this next column over here, I'm going to rewrite this as y is equal to 2. And then how many 3's do I have here? Well, I have 0 3's. So I'm going to rewrite it like that. And these are the same, these have the same value because 3 to the 0th power is just 1. And so 2 times 1 is 2, and we have 2 over here. And then for the next row, we have y is equal to 2, and then there's 1 3, so I can say times 3 to the 1st power. These are the same, have the same value. And then for my third row here, I have 2 3's, so it's going to be 2 times 3 to the 2nd power. And then over here, I have y is equal to 2 times 3 times 3 times 3. I have 3 3's. And so it's going to be y is equal to 2 times 3 to the 3rd power. Now, you may notice here that the exponent that I have on my 3 at each of these rows has the same value as my x at that row in the t-chart. Let me just highlight that. Let's see. I'm going to use pink. So this 0 here is equal to the exponent on my 3 there. This 1 is equal to my exponent on my 3 at that row. There's a connection there. So I can rewrite this function, or write it as a proper function in this form. So it's going to be y, I'll write it over here, y is equal to 2 times 3 to the x power. Y is equal to 2 times 3 to the x power. So if we wanted to know, for example, what the 6th row here was, skip some steps here, what the 6th, or sorry, when x is equal to 6, what the y value is equal to, that would just be 2 times 3 to the 6th power. Let me rewrite this function down here. So this is y is equal to 2 times 3 to the x power. And the parts of this is an exponential function here. And the parts of the exponential function, we call this our initial, or our starting value. And then this number right here, this 3, this is our common ratio. Because that's the number that we're multiplying by to get to the next step in the t-chart. Oh, I wrote ration, not the common ration, common ratio. Oops, there we go. So linear function over here in blue, and this in red on this side, this represents an exponential function. And the key understanding here, exponential function, the key understanding is that with a linear function, we have a common difference at each step. We add 3 each time. With an exponential function, we're multiplying by a number each time. We can multiply by 3, we can multiply by 100, we can multiply by a tenth, has to be positive, but we can multiply we multiply by a consistent number to get to the next step in the equation there. So again, this is an exponential function. The parts of it, this is our initial value, which that's our first y value here, which is 2. And then our common ratio is what we multiply by at each step to get to the next step in the function. So exponential functions here in red.